let's go over these bell ringers. I saw most people had the first two down, so I'm extremely proud of you for that. 75 is, oh, I'm frozen. That explains it. $75 is 25 times 3. I agree with that. So really we're doing 5 times 5 times 3. So 5 can go on a date, so we have 5 square roots of 3. Or you gave them a divorce and said square root of 25, square root of 3. So you got 5 square roots of 3. Some people jump straight to the answer, so either they're so good they did it in their head, or they use their calculator. Back to using your calculator is great, but look at number 1 for Wednesday. It starts including variables. When there are variables, the calculator cannot do it for you. So we still got to know what we're doing. For 192, I saw that was 64 times, what did you have, Emmy? 64 times what? Was it 3? Okay, which is really 8 times 8 times 3, which is 8 square roots of 3 because the 8's go on a date. Or we could say it's 64 and 3 get a divorce. I know the square root of 64, that's 8, so 8 square roots of 3. Either way, I get 8 square roots of 3. Okay, I spoke to some people about number 3. Almost everyone I spoke to, at least, they had selected A. They were tricked. The answer is not A. Ooh, good grief. The answer was not A. You were tricked. Here, let's talk about how you were tricked. Actually, let's talk about why A is not the answer choice I would choose. Look at all the other answer choices. Don't they all have the number 2 in them? So if I'm going to eliminate an answer choice, I'm actually going to eliminate A. It's not A. Now, how did you pick A? You did x times x and got x squared. Y times y and got y squared. Z times negative z and got negative z squared. But that's not how the distributive property works. So you actually have to distribute the x to every single term, and then the y to every single term, and then the z to every single term. So it's much more complicated. So x times x, yes, that is x squared. X times y, well, that's xy. X times negative z, well, that's negative xz. And that's just with distributing the x. We have to go back and distribute with the y, and go back and distribute with the z now. So if I distribute with the y, x times y, y squared, y times negative z, that's negative yz. And then I'm running out of room, but last but not least, we have to distribute with the z. So that's z times x, that's xz. Z times y, that's yz. And then with my last one, I would get negative z squared. Now, I know you might not have written it in the same order I did. I purposely put like x in front and z in back because I have to start thinking about the alphabet just so I can combine like terms a little easier. Okay, there's no other x squared, so he's all on his own. Y squared doesn't have a friend either, so he's on his own. Negative z squared doesn't have a friend either, so they're all by themselves. And notice B, C, and D all start off like that. X squared plus y squared minus z squared. The issue is what's going on down at the end. So I see we have a negative xz and a positive xz. Those two should cancel out. We also have a negative yz and a positive yz. Those two should also cancel out. So all I see left is xy and an xy. Well, they're both positive, so I get positive 2xy. So my answer is actually B. Are there any questions about that one? You know, you could always do what we did with an example last week. If you want to pick a number for x, y, and z and plug it in, only one of those statements is going to hold true. So if you pick x is 1, y is 2, and z is 3, and plug in 1, 2, and 3 into your problem, and then plug in 1, 2, and 3 into your answer choices, the only one that's going to work out is answer choice B. Okay, if there aren't any questions about that, let's move on and go back to our notes that we were supposed to do on Friday, but we took a break instead. So on Friday, instead of doing the 4-3 side of the notes, we actually did our puzzle, which is why it was supposed to be due today, but I get life is hard, and it was Halloween weekend, and you actually do have a life. You don't just do math all day, sadly enough. Okay, so last week we did 4-1, and that was really easy. We talked about the way to classify by your angles. You can be a right triangle, an acute triangle, and obtuse triangle. And then we also talked about classifying by sides. You could be scaling, isosceles, or equilateral. And so that was all 4-1. And then in 4-2, we talked about triangles add up to 180 degrees, but I think you already knew that. Then we talked about you're creating a lot of work for yourself, like on number 3. I know that 3 angles in a triangle add up to 180, but I don't have to do x plus 2x plus 90 equals 180. If there's a right angle, the other 2 have to add up to 90. So you're just creating more work for yourself if you don't do that. And then the most important thing we talked about with 4-2, which is what that Alaskan joke was about on your puzzle, is the exterior angle theorem. It said that if you take the outside angle, it equals the sum of the 2 remote interior angles, so the 2 angles furthest away from it. So you add the 2 furthest away, and you get your outside exterior angle. So if you got all that, then you'll be happy to hear 4-3 is not that complicated. So tomorrow we're going to do a study guide, and then Wednesday we're going to take a test, and it should be our best test grade ever, because so far triangles just seem easy peasy. Okay, today's notes. I've somehow misplaced mine somewhere. I hate when I do that. Did I hand you mine a second ago, Riley? Do you mind if I steal it from you? Thank you. That's what I wanted. No, that's not what I wanted. Oh, I should probably know. Okay, the geometric figures that are the same shape and same size are congruent. And if they are congruent, all congruent or matching parts of each polygon are congruent to one another. Okay, so what we're going to talk about today is if you're given 2 congruent triangles, actually matching up the order of the letters, that matters. So this is what I would put a star by, because this is where a lot of people go wrong. The order of the letters matter. The order of the letters matter. So, for instance, we look at these 2 triangles, and they look like they match. But when we start listing off the, if we start trying to name the triangle, I know your gut reaction is to name that triangle ABC, because, trust me, I want to name it ABC as well. I don't know why they did BCA. They just wanted to be weird. So if you're wanting to say 2 triangles are congruent, if you call this one ABC, you've got to be careful about the order of the letters you use on this triangle, because DEF might be different than FED, might be different than EFD. So sadly, the alphabet really came into play. So angle A had 1 rainbow, and it was the first letter. So since angle F has 1 rainbow, it needs to be the first letter on our second triangle. Now we did B next, and B had 2 rainbows. So it makes sense that angle E has to go next because it also has 2 rainbows. And then we could say process of elimination. That means this last letter has to be D. But it even matches. C was the 1 dot, D was the 1 dot. They had to go in that spot. Are there any questions about that? Or you see why it was important to name it FED and not DEF just because you wanted to. We have to play, I'm going to call it rainbow match. Or we could play side length match, because if you pay attention, and we can do this exact same triangle, we're going to figure it out the exact same way. I said triangle ABC, but instead of using the angles, if we looked at the side lengths, the first side we did was AB. It had 1 dash. So the first side we need to do would need to be FE because it also has one dash. And then the next side we did was BC. Notice it was the 2 dash, so our 2 letters better be a 2 dash piece. So it has to be ED because that was a 2 dash. So the order of the letters matter when we're comparing triangles, even if we're comparing rainbows with their angles or the dashes with their side lengths. The order matters. Okay, so if you understand that, that's the main gist of today. So, of course, those properties we discussed in the last chapter with, like, reflexive and symmetric and transitive, they still work with triangles. So, and then, it bothers me they didn't put the triangle symbol. If triangle ABC equals triangle ABC, that's the reflexive property. If triangle ABC is equal to triangle DEF, then triangle DEF is equal to ABC. That's symmetric, where we just flip them. And then transitive can happen still. We can skip the middleman, which in this case is DEF. So basically, just keep in mind those properties we learned last chapter, they work for triangles, and they're going to work for all shapes. The reflexive, symmetric, and transitive property, they work for everything in math. There's no off limits. Okay, so we're told that triangle ABC is congruent to triangle DEF, and then they want us to find X and Y. The first thing I do is I go play angle match. So if A, I'm going to give him a 1 rainbow, then I better give D a 1 rainbow too. Let's say B, he's the second letter, I'll give him 2 rainbows. Well, then I better give E 2 rainbows too. Same thing with C. C is the third, so I'll give him 3 rainbows. F would have 3 rainbows too. And now I've made my life so much easier because now I know exactly who to set equal to who. For instance, I know 5x plus 2 equals 87 because those were the 1 rainbow pieces. So if I subtract 2, I get 5x equals 85. If I divide by 5, I get x equals, it's dangerous when I start doing that, 17. And of course, it would be smart to plug it back in and check it. 5 times 17 plus 2 really is 87, so I know I'm right. Okay, if I wanted to, and they didn't ask me for this, if I wanted to, I could put a number on angle B. I could put 42, because angle E was 42, and they were the 2 rainbows. But they didn't ask me for that. I'm just doing it to prove that I know what I'm doing. And then I was going to set 3y equal to whatever was over here, but there's nothing over here. Does that mean 3y equals 0? No. 3y can't equal 0. So what if I don't have anyone to set them equal to over here? So forget this second triangle. Is there some way I can solve this first triangle now? What are triangles supposed to add up to? 180 degrees. So why don't we add the 3 angles? 87 plus 42 plus 3y equals 180. So 129 plus 3y equals 180. Someone's going to have to do the math for Miss Compton because I don't know what 180 minus 129 is today. 51. Thank you, dear. I divide both sides by 3, and I get y equals, you with the calculator? 17. And of course, I could check it and do 3 times 17, and I would get 51. And I could always say, well, is this really true? Did 87 plus 42 plus 51 really add up to 180? 7, 8, 9, 10. Yes, it did. Woohoo. I'm not crazy. So there's never a need to ask Miss Compton, specifically me. There's never a need to ask me, hey, Miss Compton, am I right? Just check yourself and you'll know whether or not you're right. You're wanting 100, right? Check it. Plug in the value you got. Then there's no need for even me. You got this. Are there any questions on number 1? Okay, well, I will do number 2 with you, but you realize eventually you're going to be on your own with this. Number 2, if I give H 1 rainbow, then I need to, on this other triangle, give T 1 rainbow. If I give J 2 rainbows, then I need to give R 2 rainbows. If I give K 3 rainbows, then I need to give S 3 rainbows. And yes, seriously, that's what Miss Compton sits there and does first. I give everybody rainbows, because then suddenly my life is so much easier, because I know who goes with who. For instance, I know 51 goes with 6A minus 3. So if I add 3, I get 54 equals 6A. If I divide by 6, I get 9 equals A. I could, of course, plug it in and make sure. 6 times 9 minus 3, 54 minus 3. Hey, that is 51. So I know I'm right. So I solve for that angle. And then I see Miss Compton put her rainbows on top of that. Is that a 73? What's the number inside angle R? 83? We all agree it's 83. Okay, well, so I can put an 83 on J because they're the 2 rainbows. And then exact same as last time, I don't see anything to match on the 3 rainbow piece. I'm not going to say 7B minus 10 equals 0 because that's wrong. I'm instead going to add them all up and set them equal to 180. So 51 plus 83 plus 7B minus 10 equals 180. And Miss Compton's out of room, so she's writing it to the right. My bad. If I combine my like terms, I get 43, 41, 83, 134 plus 7B minus 10. So 180 equals 124 plus 7B minus 10. Okay. Subtract 124 from this. What's 180 minus 124? Calculator 1.
180 minus 24.
124. 456? I don't know. I want to say 56. I want it to be 56. Okay, good. And if I divide both sides with 7, I get 9 equals B. And if I was smart, I'd plug it back in and check myself. 7 times 9 minus 10, 63 minus 10 is 53. And then I could add them all up. 51, 83. Miss Compton's math was off somehow.
So I think 56 divided by 7 is 8.
Thank you. So 56 minus 10, which would be 46. 6, 7, 8, 9, 10. Perfect. Thank you, dear. You're the best. Okay. With Ellie's help, we finally reached an answer. I know I'm right because when I add up those 3 angles in that first triangle, I get 180 degrees. Now, do I actually physically expect to see the check on your paper? No. I get you have a handy-dandy calculator and you just typed it in there. But I'm going to feel sorry for you and take off less points if I see you tried. For instance, on this last test, those who tried to show me they added up to 180, I can give them points for that. Okay, are there any questions on those first 2? Okay, well then this last one's even better. And I know there's one like this on this test on Wednesday, so if you want to know what's coming on the test, I know there's one like this on the test. Okay, so we're told these triangles are congruent, and of course I did THS and War for Warriors. Okay, so I go through and still do this rainbow thing first. So angle T goes with angle W, angle H goes with angle A, angle S goes with angle R. I play angle match. But you can do more than just angle match, and we're going to have to this time, because if you look at that first question, it doesn't ask about an angle. It asks about a side. So I know TH goes with WA, so if TH gets 1 dash, WA gets 1 dash. So if I'm really being smart, I can go ahead and start transferring numbers. If T was 1 rainbow, then W was 1 rainbow, it's a 52. H was 2 rainbows, A is 2 rainbows, it's 88. WA was a 1 dash, and it had the number 10, So TH is a 1 dash. It also needs the number 10. And then I see HS and AR go together. So if HS has 2 dashes, AR needs 2 dashes. Well, that means I can put a 14 over here. And then I know they're super far apart, but T and S go together. So W and R go together. Or just process of elimination. That's the only side left. So I get to put a 21 over here. There's one last thing it would be smart for me to do before I even read the questions. What would that be? Be real smart. Is there anything missing on our pictures? I agree. So let's solve for angle S. So 88, I'm going to put an X there for now. 88 plus 52 plus X equals 180. Thank you, dear. 140. X equals 40. There's 180. So I got 40. Which means this angle has to be 40. And then it'd be smart for me to check 88, 52, 40, 10, 1, 180. Perfect. I know I'm right. Okay, now that I've filled in everything, I can handle these questions. So it says TS, and they want a number. What number is TS congruent to? 21. So we're going to fill in a 21. Or if they're wanting an actual piece, because I don't really know what they're wanting. Actually, I do know. They might instead, because they put that congruent symbol, they're not wanting a number. They might be wanting 2 letters. So what segment is TS congruent to? WR. So I'm going to put both answers just because I'm not sure which one they're wanting. But if we're really using our brains, if it has the congruent symbol, they're wanting letters. If it has just the equal to symbol, they're wanting a number. We've talked about that before, but never hurts to cover all our bases. So HS is 14. And then you know it goes with AR. But they're actually wanting that one and wanting that one if we're being real picky. And we're not being that today. Okay, what number is inside angle W? 52. And then they said angle R is congruent to what angle? So what angle is angle R congruent to? Angle S, because we're looking for who else has 3 dashes. R had 1, 2, 3. The other with 3 is angle S. Now you and I both know that they both measured 40 degrees. So is it smart to put that as well? Probably. Doesn't hurt anything. And then they done went and changed the letters on us. So if we can do this, then we understand what we're doing today. So it says triangle HTS. So H had 2 rainbows. So what's the first letter I need to put? A. Okay, it was T next. T had 1 rainbow, so my next letter needs to be. And then just process of elimination, the last one's R. But if we looked anyway, S and R both had 3 rainbows, so it makes perfect sense. If you can do that, you understand congruent triangles. Okay, are there any questions about this? On Friday, we passed out this giant worksheet, and I'm not saying it's not bad practice, because it is. You're not going to be required to do all of them, though. I only need to do the ones that are 4-3, which is just 14 through 19. This is all I need. So since this is all I need from you, and I don't even need that much from you. That's a lot of work. Let's see. I need 14, 16, and 17. We're only going to make you do 3 of them. I'm only giving you 3 problems. It was on the 14. You got it Friday. Did you not get it Friday, Jennifer? You need one? Yeah. Okay. Otherwise, I'm going to say 4-3 is pretty easy. I think you can handle it. It's more important to me that you finish that giant puzzle from Friday. So I'm going to let you get back to work on that. If I call your name, it's to come see your test. Oh.